Hello and welcome to this video. In this video, we'll be designing a fan dipole for 40 meter and 20 meter using MMANA software. So let's get started. Let us start as usual in the geometry tab. Let us name our antenna as fan dipole 40 meter 20 meter. You can name anything you wish. We are not going to put anything in the default frequency because we'll be working with two different bands and two different frequencies. We'll be working with 7.1 megahertz and 14.15 megahertz. So we'll be changing these frequencies in the calculate tab as and when required. Let us go to the wire edit section and draw the antenna. I'm going to choose exact plane. I'm going to draw a random length of wire. We are going to add length a little bit later. I'm going to right click and divide wire into three pieces. I'm going to drag one end of the wire to make an angle this way. Similarly, I'm going to make another angle on the other side. I'm just going to press OK. In the view section, you can see the three wires. I'm going to select center wire, right click, and in wire definition I'm going to enter 0.05 as the length. Press OK. This is just 2 inches of length. If you zoom in, you can see this small piece of wire. I'm going to make one element of the 40 meter dipole, which we are defining right now as 10 meters, which is the quarter wavelength of 40 meters. I'm going to make the other element 10 meters too. I'm going to again select the center piece of wire, right click. I'm going to add source to the center of the wire. We have now defined the 40 meter dipole. We'll go back to the wire edit and add a 20 meter dipole. I'm going to zoom in and I'm going to change the ends of the center wire a little bit such that they are on one of the points here. Let me see if I can do that like this. Now it is on perfectly on the two lines. This helps us in adding the 20 meter dipole. Okay, now both the points are on the lines. Now with that, I'm going to just add another dipole with a certain angle. We are going to define the lengths and the angles a little bit later. Okay, so I press OK and let us just check if they are perfectly aligned. Yes, they are. I'm going to right click and in wire definition I'm going to check the length and change it to 5 meters, which is the quarter wavelength for 20 meter. Similar way, I'm going to make the other wire element as 5. Okay, so now we have created a fan dipole. Let us check the performance of this dipole. We go to the calculate tab. Let us first select 7.1. So we are going to first check the performance of the 40 meter dipole at a height of 10 and with material as copper wire. I'm going to press start. It is giving SWR of 1.35. Not bad. We'll go to the plots and check the SWR curve once to see where the antenna is resonant at. Right now it is resonant at 7.128, but we want it to be resonant at 7.1. Now here we cannot do wire scaling as we have done in previous videos because there are two sets of dipoles, and by doing wire scale the other set of dipole, which is the 20 meter, might change its length as well. So we are going to do it manually. We want to go from a higher frequency, which is 7.128, to a lower frequency, that is 7.1, which means that the lengths of the elements have to be increased. So I'm going to go to a view and increase, and I'm just going to uncheck the currents and select the 40 meter dipole element and make the length as, let's say, 10.05. Earlier it was 10 meters, so the new length is 10.05. Similarly, the other element I'm going to make 10.05. Let us go back and check the performance once. Okay, so the SWR has not changed much. By doing the change, let us see where it is resonant at right now. Okay, it is resonant at 7.1, so the R value is 67.49. We can actually reduce this R value towards 50. We can change this R value by changing the apex angle of the 40 meter. This is our 40 meter antenna element. I right click on it, and in wire definition I can change the angle. We need to decrease the angle. I'm going to make the angle 115, which will decrease the angle. You can see it in the background. There you go, it has decreased. I'm going to right click the other element and input 65, which is going to decrease the angle. There you go. Since the elements of both the dipoles are very close to each other, I'm just going to decrease the apex angle of the 20 meter dipole a little bit for time being. So excuse me, I'm going to make this 125 and this to 125 also. Okay, so let us calculate for 7.1 and check what is the result. Here you see that the R value has decreased further and the SWR has improved. So as we get closer to the matching, the SWR will be better. Let us see the plots once for the SWR curve. It is 7.118, so it is quite close to 7.1. Let us check the performance of the 20 meter dipole. Let us check at 14.15 maybe and press start. Okay, here the SWR is very high right now. Let us check where is it resonant. It is resonant at 15.2, so we need to bring it to 14.15. That means we need to change the length or rather increase the length such that the resonant point shifts from 15.2 to 14.15. I'm going to do the changing of lengths manually, since with wire scale it will disturb the 40 meter dipole also. So I go to the view excuse me, and I right click the wire length and I'm going to enter, let's say, 5.3 on both the sides. Let us check the performance. Here you see that it has improved drastically. Let us change the length further a little bit to, sorry, should change for this element. Let's go to 5.38 and check. Okay, it has come down to 1.43. Let us plot and check the SWR curve. It is at 14.2, so we can increase the length a little bit more. So let's say 5.4. And check where it is resonant at. Here the SWR has gone below. Let us check. 14.17. We can still increase by a very fine margin. Let's say at end of 405. Uncheck once. Okay, still the SWR has gone below, which means we are arriving closer, and right now it is exactly at 14.15. And the SWR is at the extremes is 1.6 on 14.05, and on the other side it is close to 1.5. We can use the LC match or any kind of antenna tuner to match the two sides, that is the TX side and the antenna side, so that the maximum power transfer occurs and the SWR goes even below. Of course, one should note that there will be some power loss occurring in these elements. So if we go to 7.1, it is 1.15, and at 14.15 it is 1.14. So we can change the lengths and the apex angles for both the dipoles such that they are tuned at the desired frequency. Let us see the far field plots for 7.1. Here you can see that the far field plot is similar to that of a horizontal dipole. Maximum gain is occurring at 90 degrees elevation angle. The gain is 5.9 dBi, and at an angle of 38 the gain is 0, and it goes on increasing as we go towards 90. So maximum radiation is occurring between 38 degrees and 90 degrees on both the sides. If we change it to 20 meter and press start, we can see the far field plots of the 20 meter band. I hope you enjoyed this video. If you have not subscribed to my channel, please do so. Also press the notification bell so that you will be informed when I upload new videos. Thank you for watching.